Thank you everyone for joining us on the CloudNative.fm podcast. This is your host Saim Safdar and this is episode number 40. And today we talk about Kubernetes and Kubernetes storage, CSI, how these things evolve. And today my guest is Saad Ali. He's a senior software engineer at Google and he's been a part of so many great things. So it's my privilege and honor to talk to him on this shows today. Over to you, Saad. Introduce yourself to my community and thanks very much for being on the show.
Thank you for having me, Sam. I'm a staff software engineer at Google. I've been working at Google for just about 8 years now. My focus initially was a completely different team, and then I got pulled into Kubernetes, and I've been working on Kubernetes since before 1.0. My initial focus was on storage. And that's kind of the area that I've specialized in and focused on since then. Happy to answer any questions you might have.
Yes, absolutely. First, thank you very much for being on the show as well. And it's been a privilege. Like I have talked to so many Googlers before in the past as well, because the company behind the open source tool that we all love about, that is Kubernetes, and it's been every time I join anyone from the Google, I learn so many new things about Kubernetes, how it's originated, how it's evolved over the year, and you've been in the part of the team, like you're a 78-year-old the Google, and you know these kind of early adoption, like people are talking about Kubernetes. We saw the documentary out on the internet about the Kubernetes, the documentary, and we've seen people talking about how it's actually started, like Joe Beda, Brendan Burns started about the Kubernetes. So tell us about your experience. When you first heard about Kubernetes, what your first thought was? Is going to be hit? What is going to be happen? It's our change, our mindset, our mentality of adopting and running apps.
Yeah, so my background was actually, I worked at Microsoft for about 3.5 years out of college. And so when I was at Microsoft, I was working on Hotmail. And so Hotmail is a massive web service, and I was kind of intimately aware of some of the struggles that we had in terms of being able to deploy a large-scale web service and figuring out how to do the monitoring for it. If something went down, how would we kind of be alerted to that and resolve that? And challenges around just figuring out how the actual deployment mechanism worked, right? Like, are we doing a bunch of PowerShell scripts? How do they get executed? How do they get on the machine? And anyway, so that was my background, and I joined Google. I joined a completely different team, and as often happens at Google, project got canceled, didn't go anywhere. That was about 11 months into my experience. And at that point, what I decided to do was look around for another team. It's a little bit like being a kid in a candy store when you're looking for a new team at Google, because there's so many cool projects going on. My old manager knew this guy, Tim Hawkins, from Kubernetes fan, of course, and they were just starting the Kubernetes project. This was, I think, winter of 2014. At that point, I talked to Tim. I really enjoyed talking to him, and the idea kind of clicked, right? He was trying to explain this idea that they had with Kubernetes to be able to do kind of these repeatable deployments and kind of a management system, and the idea that it would be open sourced. And with my background with the web services at Microsoft, I was like, hey, this would be pretty cool. Like, if I had this, it would be an awesome tool for myself to be able to use. And that was kind of the impetus for joining the team. Now, had no idea how successful it was going to be or kind of where it was going to go. It just seemed like a really cool project to join, and I enjoyed the people that were on the project. So Tim Hawkins, Brian Grant, Joe Beda, Brendan Burns, Clayton Coleman. All these folks are just kind of really fun to interact with and really nice and willing to help me understand as a junior engineer of like, hey, here's what we're trying to build, and here's kind of the dream, and you have an opportunity to help us build that. So I was kind of hooked from that. And so that's kind of how I ended up on the Kubernetes team.
Yes, absolutely, absolutely. So that's actually that's really interesting because a lot of the guests have spoken about too, but you heard about this news so early, like 2014, when things actually happening in that moment of time, and people are really figuring out the containers now came into the picture with the from the Solomon hikes during the PyCons and everybody talking about, and then think about the Kubernetes came into being in 2014. So there is so many things going on at that moment of time. Some of the people are working on the networking side of the Kubernetes. Some of the people working on the ingress control or the proxy side of the Kubernetes. Some people are working on service meshes. But you got into the situation like the story that's quite really complex and quite really a very worried topic because you want to lose data. What's going to be happen there? So you started jumping into the very like a brave field, like the story side. So tell us about how actually the CSI started, what was the theme behind it, and what are the people behind this project, and how you look at this space when it's early on the Kubernetes side.
Yeah, happy to talk about that. So I'm not a storage guy. I know storage experts, and I respect them a lot, and I will not pass myself off as a storage guy. My background was in storage, and the way that I kind of got pulled into Kubernetes storage was a little bit accidental, right? Early on, everybody was kind of working on everything. So, for example, one of my early projects was doing event deduplication, right? Originally, events in Kubernetes were stored in the same etcd as regular resources. And if you had the server or the cluster generating too many events, it would actually knock over etcd and bring down Kubernetes. And so, before we actually pulled events off into a separate etcd, one of the things that we did was implement event deduplication. And so, I was working on kind of a bunch of random things for Kubernetes as needed. And I started fixing bugs around storage just because that was what was needed. And eventually just, one bug after another. And Tim's like, hey, do you want to kind of just, be the storage person and do a lot of the storage stuff? I was like, sure, why not? And that's kind of where it started. We by that time had a group of folks from Red Hat and Google who were really kind of focused on storage. And we created a little storage SIG. I think there was like 6 or 7 members at the time. And the focus was really trying to, in the beginning, it was really around stability. I think the original storage stack was kind of a good proof of concept, but very unstable. And so the early work that we did in SIG storage was really actually 2 things. One was around the idea of introducing dynamic provisioning, which is kind of fundamental to the way that Kubernetes operates storage, right? The idea here is, previously, when you want to use storage, it's kind of on you to figure out how to provision that storage. And then Kubernetes came along and said, okay, we'll make it very simple for you to consume that storage. But in the initial kind of implementation, there was no dynamic provisioning. So you were still on the hook for actually provisioning that storage. And then after we did dynamic provisioning, it basically allowed Kubernetes to manage the full lifecycle of your block and file storage. And so Kubernetes was able to not just kind of integrate and move your storage to where it needed to be, where your workload was, but also actually provision that storage on demand as needed. And so that was kind of the powerful fundamental differentiator between Kubernetes storage versus other offerings at the time. And so once we had dynamic provisioning, then it was really about stability. And so I think Kubernetes 1.3, we did a big refactor of the persistent volume controllers. We actually split out the attach-detach controller as a separate controller. So even from 1.3 to 1.5, 1.6, there was a lot of work done around stability. And then eventually, once things got stable, the focus was on extensibility. right? We wanted Kubernetes to be Kubernetes storage to be extensible, right? We want Kubernetes to be a system that'll work for a bunch of different needs. And rather than try to do everything itself, Kubernetes itself tries as much as possible to be extensible. And so with the storage stack, what we wanted to do was be able to integrate with arbitrary block and file storage. At the time, the way that you did that was actually writing code within the Kubernetes code base. That meant, if you're a NetApp or Dell EMC and you want to integrate your storage with Kubernetes, you'd have to come talk to SIG Storage, get on the agenda, maybe, and actually write code within core Kubernetes that would be an extension for, whatever type of storage system, block file storage system that you have. And that was pretty painful, right? That meant you're basically stuck on the Kubernetes life cycle in terms of being able to do releases. You have a huge amount of overhead in terms of development, and testing is kind of difficult and painful. And then from the Kubernetes point of view, it was also painful for us, right? Because you have this code that we can't really test, and if there's a bug inside of it, it's actually running as part of the core controllers, and it can bring down core Kubernetes components, which was not a good architecture. And so those were kind of the reasons that we decided, okay, let's see if we can build an extension mechanism that would allow for storage extensions to be built outside of the core Kubernetes code base. And that's where CSI started. And initially we were thinking, hey, we'll kind of tackle this for Kubernetes, but what we looked around at the time and discovered was it's a problem that a lot of other container orchestrators were having as well. So at this time, Kubernetes wasn't the de facto winner of the container orchestration space. There was a lot of players, Mesos, Cloud Foundry, Docker had Docker Swarm. And what we noticed was actually storage vendors were sitting on the sidelines and they were waiting to see, what was going to emerge before they go and commit effort to try and building plugins for each one of these systems. And so what we decided was, it would actually be beneficial to join forces with all of these different projects and try and build an industry standard together rather than build something for Kubernetes and then make the storage vendors kind of decide where they wanted to go. And so we started working with Mesos, Cloud Foundry, Docker, and we started the CSI project. And the rest is somewhat history at that point. CSI ended up being quite a hit, and now we've got, I think, over 100 CSI drivers from different storage vendors and cloud providers, and it's become a really great way of being able to extend Kubernetes to use kind of arbitrary block of file storage that you have available within your system.
Yes, absolutely. But you draw the conversation wonderfully forwarded, because on that time actually is not just Kubernetes. We don't have a winner at that point, like Docker Swarm, Mesos, and might be, I think on that day might be Nomad also somewhere started behind the scene as well. So there is obviously no winner here, and the vendors is actually looking at the people actually who is coming out of that door and tell us that actually who is the winner of, and then we start thinking about how we can integrate those solutions with that winner. And you made a wonderful point, you made a point that you created an interface, people can hook into it, and Kubernetes, that API call the interface and then do the heavy lifting for you. That's actually the model is everywhere in the Kubernetes, like in the container runtime interface, Kubernetes networking interface. That's how the Kubernetes API eventually evolved and developed, and that's why we have so many tools that Kubernetes can integrate easily with any of them. That's actually a wonderful. The people behind it, they understand that this thing has to be stay in the market for the longer run, and we have this to be a smooth experience, not just for people are using it, but also people who are developing solutions on top of it. So that's actually a whole model and whole things are happening at that moment of time. But tell us about we started this conversation of CSI. I've seen one of your wonderful talks on the KubeCon. I think it's 2019 or 2018. You talk about the Kubernetes design principle. So tell us first about how the Kubernetes design principles are, and also in terms of the storage side, what you think is still be the most powerful things in the Kubernetes, And if people are developing solution on top of it, how to go about the design principle or the best practices that you want to throw into the people's mind.
Yeah. So I think go watch the talk if you're interested in the design principles. I think I'll touch on some of them here. Basically, one of them was really meet the users where they are, right? And the idea there was when you build a tool like Kubernetes, there are a lot of existing kind of deployments that are already out there. And rather than making customers and users like rewrite their entire application to fit the Kubernetes model, Kubernetes should kind of adapt as much as possible to these existing models to lower the overhead for deploying these existing workloads. And so we made these trade-offs constantly, right? So for example, in the storage subsystem, one of the capabilities that we have within Kubernetes is that you can reach out from within your application to talk to the Kubernetes API to, for example, fetch secrets or config maps, basically configuration information about arbitrary things. And so if that was the only mechanism that was available, then what that would mean is that your application, if it was deployed on Kubernetes, would need to be re-architected to talk to the Kubernetes API to fetch secrets and config information. But what we said is, well, a bunch of applications actually already consume this type of information from a file. And so that's where the idea of having kind of these ephemeral volumes, config map volumes, secret volumes came from. And the idea was basically, you can have these existing applications that read from file, will go talk to the Kubernetes API server, grab this information, and then push it up into the container as a file. And so that way your application doesn't actually need to change the way that it's been working. It'll kind of just work the way that it is. And so there's a number of these principles that we applied as kind of design principles when Kubernetes was being built that kind of apply throughout the project, not just for storage, but other pieces as well. And then specifically talking about kind of the CSI, I guess your question is related to kind of how production workloads take advantage of CSI drivers, or how folks should be writing CSI drivers. Is that what you're interested in?
Yes, absolutely.
Yeah, so I think my recommendation there is, if you are a storage vendor who's interested in writing kind of CSI drivers on your own, take a look at some of the established ones. GCPD is fairly well written, and the NetApp folks I think have done a good job writing their CSI driver. They're really involved with the community. So take a look at some of the existing CSI drivers. If you go to there's a documentation page for CSI driver authors. You can actually see a list of all the CSI drivers that are out there. It's self-published, so folks who write a driver can optionally put their name on that list. And a lot of it is open source, so you can go and look at the code to see kind of how others have written these CSI drivers. And there's a lot of subtle nuances to be aware of as you write these things. So it's good to read through that documentation and also look at the drivers that others have implemented. And then kind of stepping away from the storage vendors to folks who are actually deploying storage in their own environments. It's a non-trivial problem, right? It's Kubernetes has made it easy to kind of integrate with storage and to consume storage, but the problem of actually deploying storage, it's outside of the scope of Kubernetes, right? So if you are deploying a new cluster, you still need to figure out, what is my storage system going to be, and then make sure that you do the appropriate kind of CSI driver deployment and configuration to integrate with that storage. And so the challenges that you want to worry about there are kind of the classic problems with storage, the trade-offs between availability and reliability and cost and so on. And so, if you're in an on-prem environment, You're going to want to decide whether you want to go with kind of an open source free solution or some sort of paid vendor solution. And in either direction, especially on the vendor side, are you going with a only software defined storage solution? Or are you going to go with an appliance? And, all of these options are going to have trade-offs that you're going to have to consider. I think there's a trope, right? People love to say storage is hard and storage on Kubernetes is hard. And the reality is that Kubernetes has done a lot to make the consumption of storage and kind of integrating block and file storage with Kubernetes a lot easier. But fundamentally, Kubernetes it isn't a storage system, right? You still need to bring your own storage system, and the selection of that storage system and the deployment of that storage system is still a problem that you need to grapple with. And so you need to understand kind of the fundamental trade-offs between different options and kind of manage your storage deployment. Of course, if you're on the cloud side, that's not a problem because, you have solutions like GCE persistent disks or GCE file store that are available to you where they're basically fully managed kind of storage solutions for you. And really all you have to worry about is kind of the integration. And even there, if you're using a solution like GKE, it'll come pre-installed with the appropriate CSI drivers. So life is a lot easier.
Yes,
does that answer your question?
Yes, absolutely. I think as we drive the conversation, started about the CSI, how it started, then we see Kubernetes adopted a wonderful, the design principle that we talk about in that KubeCon 2018 and 2019. The link is available. People who are watching, who want to listen to that talk as well. So I think that's design principle actually. Kubernetes has a PV, then we have a PVC, then we have storage classes, then we have dynamic provisioning. So that is actually these design principles help you adopt those things really easily. You don't glue together things, but you have the decoupling of these projects. So that's actually a wonderful news for everyone who are adopting this kind of solution. And today I think things are really simple as compared to the 2018, 2019, because in that day people don't able to see what is actually going, the trend is moving forward. Right now is Kubernetes is there and people are now developing solutions. There are small open source solutions that make your life more easier. Like they can set up the PV, PVC and just one file and everything was on the fly for you. So I think moving forward things is going to be more simpler rather than things that are going to more complex. That's actually a good news if you are into the storage space. But tell us about Saad, if you look at between in the past, like 2 or 3 years before, do you think what is actually is a good things happening in the storage space? What you think is still missing, and why you feel right now still people are really feel challenging when adopting or running stateful app on Kubernetes? They not feel so confident, but now their confidence is gradually increasing rather than decreasing. But they're still not resilient enough to adopt the stateful application in Kubernetes. The number is very low when you look at the CNCF usage report of Kubernetes production workload, the stateful or stateless app. The stateless app is actually a large as compared to the stateful one. So tell us about why people are still facing where the issues are, and tell us about how you look at the storage space. What you think? What are the things improved, and what you still think is missing in the storage space in Kubernetes?
Yeah. So I think one thing I touched on already, right? Like the idea is that Kubernetes doesn't provide you storage. You are still responsible for coming up with your own block and file storage. And, fundamentally, that is a non-trivial problem. And so I think that's a hurdle for anybody that's kind of deploying their own environment. If you're in cloud, then life is a little bit easier for you in that regard. The other challenge for running stateful workloads has really been around, for a lot of stateless workloads, this principle of like meet the user where they are, take your existing application and just deploy it in Kubernetes kind of just works, right? Yeah, you take a stateless app, you containerize it, more or less it will just work if you deploy it in Kubernetes. For stateful workloads, you need to do a little bit more work. You need to understand, how you're going to construct your PVC volume requests. What type of storage are you going to use in terms of access mode? Is it read-write once? Is it read-write many? And what type of storage classes are available in the environment that you're trying to deploy in. And all of these kind of questions then kind of play into the nature of the stateful app that you're trying to deploy, right? Is the stateful app kind of resilient to failure and therefore capable of, doing, a replication at the application layer, or does it require, some sort of reliable storage underneath the covers and is kind of a single instance that depends on replication being done at the storage system level. And based on kind of all of these decisions, you have to kind of structure your deployment in a specific way in terms of how you can structure PVCs, whether you use stateful sets, whether you use a deployment or some other mechanism, and that's where things get a little bit challenging. And where things, I guess, gets a little bit simplified there are when you have operators that kind of take away a lot of this pain. So you'll see a lot of stateful applications on Kubernetes now have operators, and we're seeing kind of more and more developed over time. But again, it's one of those things where you have to be able to kind of understand the system to some extent, and it's not it's not always the easiest to be able to kind of understand end to end, and so I think those are kind of some of the challenges that you're going to encounter if you try to deploy stateful workloads or a storage system in Kubernetes.
Yes, absolutely, absolutely. And I think when you look at it, it's a story similar to the way back in the virtual machine. Like when the virtual machine started, the cloud era started. You start up with a virtual machine come up. Then we have the first thing that's come up on top of the virtual machine, that is networking, how you set up networking, how your apps are communicating with each other, but still are figuring about the stateless app are working on that time. And then you gradually move to the era that's the storage later came up the picture in the cloud. I think that same happened to the Kubernetes space as well. The Kubernetes came into the picture. There are networking setup, application talk to each other very easily. You don't do anything else. It's hidden behind the scene for you. And eventually the next era came up in the storage. It's still difficult, still complicated. You need to set up, you need to understand how your application actually use that storage. That's another part. You just set it up. How actually, if your application is not able to use that information, that is no point of setting up all the CSI infrastructure. So now gradually the storage is getting the market, there is so many good like NetApp on the wonderful solution, then Commvault, then OpenEBS, and there are so many other solutions. And people have built out the community on top of it, like Data on Kubernetes is a great community that's work on help you educate around the data on storage side in Kubernetes. So there are things are moving in a very good direction. That is a great news actually. If the adoptness is a challenge right now, but things are moving in a very good direction, like the rest of the community is building up, the solutions are coming up, operators are coming up on the storage side, and that's where we started about the design principle in Kubernetes. You can extend the Kubernetes API, make what you want in the Kubernetes, and Kubernetes adopt to your needs. That's like a human principle that's Kubernetes adopting to itself. So before I let you go, Saad, tell us about your journey of being in the Google as well. Like the 7-8 year you spent time there, you have been part of the wonderful open source projects and some of the other projects like people not able to know outside from the Google. So tell us about your experience so far in the Google, how you look at the team, which help you most in terms of your journey of learning and adopting to technology. So tell us about your experience in the Kubernetes, in the Google.
Yeah, I think when I first started my career, I was expecting that every 2 to 4 years I would switch companies and try something new because things get boring. You get used to something, and you always want to try something new. And I think the interesting thing that I found at Google is you can actually switch around within Google fairly easily. So you can start on one team and kind of switch to another. And I think in some companies, they require you to kind of re-interview or that kind of thing. And at Google, that's not required because when you're hired at Google, you're hired for the company, and then you have kind of mobility within the company as long as your performance and these things are good. And so that was exciting, right? So because my original team got canceled, I was able to move to a different team. I found this Kubernetes team. I, at the time had no idea, kind of where it would end up. Didn't realize that this would be a very, very long-term thing. I expected, it might be 2 to 4 years, and then I would try something new. But yeah, it ended up being a fairly, exciting project with a lot of really great people, and obviously took off in the industry. And so it's been an absolute pleasure to have been involved with that, and I feel very lucky to have been involved with that. And then, of course, within Google, there's been a number of projects that have kind of spun off of Kubernetes, GKE, of course, Anthos. And then we have, of course, other projects I can't really talk about. I've been lucky enough to be involved with these projects. And, whenever I start getting bored, I always feel like, oh, yep, there's something new coming down the pipe that gets me excited. And that's basically where I am right now. So overall, it's been a really fun journey.
Yes, absolutely. I think, as you tell about it, it's really hard in IT to spending a long time in the one company, because you need to make your hand dirty with many different technologies so that you can feel not bored, but life is going to be more enjoyable. But you have done this, you have get the flavor of that, because in the Google side, there is so many things happening, like the Istio, Kubernetes, GKE, and bunch of other things like CloudRun, Anthons. So you have hands dirty with so many different technologies, and that's make you not feel bored. But I think there's a wonderful people. I have talked to them. They're really friendly, and I really enjoy the time talking to Google people. And they tell us about the story of how they got into the Kubernetes and what they feel about it. So that's a really, really a good exposure when you work with the Google team as well. So Saad is episode 1 with Saad me today on the Cloud Native FM. But I will continue to do more and more of this stuff. I want Saad to be on the more publicly visible, even people recognize his effort and see how the things are evolved over the year as well. So Saad, tell us about we hope we can find you more in the upcoming this year. So tell us about. I have seen one of your talk at the KubeCon, and when do we expect another talk from you at the KubeCon as well?
Yeah, that's a good question. I think Corona has kind of thrown a wrench in a lot of plans in the last couple of years, and who knows at this point where things are going to be in a year. So I think your guess is as good as mine.
Yes, absolutely. So, but I'm hoping I'm able to see you in the KubeCon. We can even meet and talk to in person, because in person is a wonderful experience for us. So hope to see more and more content for you. Might be able to interrupt you again for some other content in the Kubernetes side as well. But thank you very much, Saad, for being on the podcast. I really enjoyed the time with you, and hope to see you again in the future as well. Hope you enjoyed as well. Everybody watching this podcast, hope you learned about the great amount of information around the CSI and these kind. And I know if you want to find Saad on other platform, that I think he's only active on the Twitter side, and his Twitter handle is listing here on the YouTube as well. So follow him. He's been a wonderful person, always share good knowledge around Kubernetes. So he's a learning resource for you if you want to be into the CSI or Kubernetes space. So thank you, Saad, being on the podcast. Hope to catch up you again in the future. Bye bye everyone. Stay safe and stay healthy.
Thanks for having me. Take care.